introduce our next speaker, Matt
DeBergalis.
DeBergalis. Matt DeBergalis is going to talk about awesome new Node framework. This is something I'm personally really excited about, so I'll hand it over to Matt.
Thanks. I only have a couple slides. My one request is that you guys interrupt with questions. I'd much rather just go back and forth for a while than yammer on. Meteor is a JavaScript platform that I wrote with a few other folks. It's been out for a couple months now, and it's just a radically easier way to write single-page JavaScript applications. So what I wanted to do is talk for just a couple minutes about kind of how we think about this problem and what's happening in the space, and then I'd like to just write an app with you, because I think that'll give you the best flavor of what it's like to use Meteor, what we're trying to do. And again, if you have questions as we go along, please don't hesitate to interrupt. So the story here is that we're at the beginning of this shift where we're going to move applications back to the browser. And that's really exciting because for the last 10 or 15 years, we've been building apps server-side, right, in PHP or Rails or Java or whatever you like. And server-side apps aren't very good, right? At the end of the day, you can always build a better interface if your code is running in front of the person. That's why we moved from mainframes to Windows. And it's why finally now that we have browsers that are good enough and standard enough, and we have networks that are ubiquitous enough, we're moving the apps back. So that either means JavaScript in your browser, or it means Cocoa Touch or whatever else people use now on a phone, right? So that gives us a chance to just sort of rethink how to write an app from scratch. And I think what we're going to find is that a lot of the things we've taken for granted over the last like 10 years with how you structure a web app and the technologies we use are going to change. A lot of them are going to go away. A lot of them are going to evolve. And I think this is one way to look at what that new world will look like. The first thing is there's one really special language in this new world, right? Because for political reasons, the browser wars played out the way they did. So it's going to be JavaScript. That's a special language. And unlike this old server-side world where you could pick, maybe you cared about performance, maybe you cared about developer velocity, maybe you just happened to like a particular language. JavaScript's going to be special because your front-end code has to be written in it. And that means that it's a very attractive way to write your back-end code. Because if you can do everything in one language, and in particular with one API, where you don't have to think in two different ways depending on where you're talking to your database, we've found that just dramatically improves the developer experience. It's how I like writing apps. I think that's going to resonate with a lot of people. So that's the first point. Second point is, with the exception of some questions around performance and spiders, this whole presentation over the wire thing is going to go away. We're going to write APIs, and it's going to be data over the wire, not pages. You can build a better structured application that way. Everybody needs the API these days anyway because the whole web is turning into this, I think, interconnected set of applications that understand each other and can interact. So we're going to focus on this idea that we're going to use data over the wire, and the UI, the rendering, is going to be driven by client-side code in JavaScript. Again, there's going to be a special case for a couple years still with Google, and maybe just to get a first quick page load. But I would think of those as performance hacks, not as the way you really want to structure the app. And then the other thing is, and this is more just how we think of Meteor, it should just be really simple. It should be fun. I find this whole maze of technologies you have to navigate to build an app these days just irritating. So we've tried to create APIs that are just pleasant and easy to absorb, and I hope that comes out as I start building this. So some stuff's going to go away and get replaced, and I don't want to dwell on this too long, but the basic story here is APIs are going to be about real-time data on the web in the future. Look at Twitter as sort of the vanguard for this, right? They understood very early on that it wasn't good enough to have a REST endpoint where you could ask for something and get back a list of items and you were done. What you really want is the fire hose, right? You want a stream of data because it's always changing. And as you build single-page apps where you don't get this free like reset every time you reload a page, you're going to have to be delivering fresh data to the browser all the time. So obviously, we have things like Pusher, and we have Socket.io, and we have WebSockets, and that's the direction we're going, right? And I think you're just going to find these REST endpoints start to look like static legacy ways to access data, not the preferred technique for most of what people are doing. So we've written a protocol called DDP. It's something that we have sort of a working version and something we're trying to really clean up. But that's a clear way for a client and a server to communicate. We'll talk a little bit about what that means. The gist is clients get to do two things with data. They can subscribe to data from the server, so they can say, I want a list of whatever, and that list is changing over time. And they can ask the server to do things, so remote method invocation. And that has nothing to do with JavaScript, really. It's just how people are going to communicate over the wire. So the model for Meteor is the client is going to subscribe to data, and it's going to keep that data in a local cache in the browser. That means that once you have it there, access to your data is very fast. You don't have to have a round trip to the server every time you want to talk to the database. That's a model that works fine if your Rails server and your database are physically next to each other in the data center. It does not work over the internet, right? When the client wants to do something, it asks the server to make a change. Presumably, that action is going to affect the data the client subscribed to, and so new results will stream down as a result. But there's a trick, which is you usually don't want to wait for the server to show an update. If you're building a really responsive interface, you can't pay that round-trip cost. So the client can simulate what it suspects will happen to the data without waiting for the server. And we'll see that as we build the app in a really simple way. And then as the server finally shows up with the real data, which will often be exactly the same, but to the degree that they're different, the client will replace whatever it guessed with what the server ultimately did. Yes? Good. You're doing it right. The question is about stale data in the cache. So the way we think of this is that the cache is never stale. I mean, it might be out of date a little bit, but when you subscribe, that means the server is responsible for keeping your cache up to date. So any data in your cache was delivered by a server who is continuing to deliver updates as they occur. Yeah. Yeah. I'm sorry? Is it synchronous? I mean, the implementation of how that works can vary, but you know, the way to think of it is it's like the real-time web kind of synchronous, right? So the data will show up. It might take a second. The idea is if you're doing latency compensation, right, it doesn't really matter if it takes a second because you can make your local changes immediately. And you know, someone else posts a comment on a Facebook story, it's okay if it shows up a couple seconds later, right? That doesn't affect the usability of the app. So that's the story for data. The other thing you need in a real-time app, which we have seen, I think, a lot of great work on this front, is how do you make your display react to the data as it changes in the cache? So we've written a technology that allows you to use any templating language you like, but have that screen redraw automatically. It takes care of a lot of the ugly corner cases that are really annoying. So for example, if you're in the middle of typing in a form field and we have to redraw the screen for some reason, we obviously don't want to lose your text input. We don't want to lose the state of your accent character input if you're halfway between like a UTF-8 character, right? These are things that are just incredibly detailed. You don't have to bind to changes as they occur. You don't have to worry about garbage collecting zombie handlers once your original version of the template got redrawn off the screen. And we're going to make sure that your event handlers bind to the data that was used to render them, not the actual DOM. And I'll show you what that means in a second. Does that all make sense? Maybe? OK, enough slides. So let me see if I can just give you a sense of what it's like to build an app. So let's create, I'll just create an app called Demo. Obviously, I've done that before. Wait a minute. How about I mirror the screen? OK, so all I did is I just asked to create a new application. And inside my demo directory, I have a couple of files. Can you guys read this? Is that big enough? OK. And to run the app, I can just run it with running the Meteor command. And I now have a little demo application running here in the browser. Pretty small screen. We'll see if this works. OK, so the first thing is just like Meteor apps are really small. There's just not a lot here. And in fact, I'm just going to delete basically everything that's in the HTML that we get for free. And I'm going to delete everything in the JavaScript. OK, so what I want to make is just a little demo where we have a list of players on the screen and you can increment their score. It's one of the examples we built on the website. And again, it'll just give you sort of a flavor. I'm going to use a couple things here that we give you out of the box, but you have choices. So one is Mongo, which I think is a great fit for most sort of straightforward single-page apps. And the other is Handlebars, which we saw a bit earlier, too. So you can use a different template engine if you want, but we find that it works really well. So let me just draw a template real quick. I'll make a template named Players. So template, and we just define this in the HTML by creating a template stanza. And what I'll do is let me wrap this in a div. I have some CSS, so I'll try to get the class names right here. And we're going to iterate over a list of players. So let me just add a couple lines, and then we'll come back and talk about what this means. But you know, the HTML is going to look pretty reasonable. There's always a hazard of doing this live. OK, something like this for our HTML. So all I've got is a template named Players. This is the Handlebars syntax for rendering that template, the little greater than symbol. I have an iterator, each, which is just going to loop over some argument called Players. We haven't defined that yet. That's going to be my set of players that I'm putting on the screen. And then for each player, I've just got a div with two fields, name and score, for each player. Simple enough, right? So let me come over to the JavaScript file. The first thing you'll see this is if Meteor is client. So in Meteor, you can write code that runs on both the client and the server. So I'm going to keep this stuff just on the client. And I need a couple things. The first thing is a place to put all these players. So let's just define players as a Meteor collection named players. What that means is I want a Mongo collection called players. So the argument to the function was the name of the collection on disk. If you're familiar with Mongo, this will look like really straightforward Mongo stuff. If not, you'll find it's a pretty intuitive database. And I kept that outside this is client. So this is actually running on both the client and the server. So I've defined a collection that's going to be available in both places. And then I just need a couple of things. I have a template. I named the template players. And then I have this helper function I'm going to need called players. So template.players is my template. And I can define a helper, players. And all I want to do is return the contents of the database. The open, close, curly is Mongo syntax for every matching document. And that's it. So I save my HTML and my JavaScript, and I come over here, and now I have a blank screen. Maybe we can just add a little headline here. In Meteor, when I save files, the browser updates automatically. I don't have to deal with this whole reloading business. That's true for CSS and JavaScript and HTML. And forgive me, because I want to copy in. The one thing that doesn't make sense to do is to write CSS in front of you, which I don't know very well. OK. So I don't have any data in my browser right now. So I just have this players h1 and nothing else. So we can insert something into the database. So I can just do that with players.insert. So collections give me the insert method, and I'll just give it a document with, it's a JSON document. So name Matt, score 25, let's say. And there it is, right on the screen. This is a real-time app. So whatever I'm doing in one browser is available in the whole world, right? It's persistent. So if I reload the page, the data comes back from the server. And if I add another player, Joe, and I give him a score of 2, that'll appear in both browsers at the same time, right? So we didn't have to write any of this code. It's just this really clean, simple way to think about. I have collections. I have, in a default Meteor app, my collections are available on every browser. And then I rendered a template that just spoke about iterating over the set of items in the collection and put them on the screen. So as they change or as people add new ones, I don't have to do anything else special. Make sense? So the next thing I want to do is let me just show you what it's like to modify some of these things. So I want to add another div, and I'm going to create a button so that we can increment a player's score. So let's just do an input button, add 5 points. So I save that, and I get my little button down here. OK, so I want to have a concept of a current player that I'm working with, and then when I click the button, I want the score of that player to go up. So I'll do a couple of things. In my JavaScript, the first thing I want to do is I want to be able to keep track of a current player on the screen. So I can define an event map. This is going to look very familiar if you've used Backbone, for events on my template. And the event I'm looking for is to click on an input. So I have an event, and then a space, and then a CSS selector. And events run functions. So my function, all I want to do is set a session variable. This is local storage on the client. So set player ID to this.id. So there's a little bit to talk about here. First of all, every document in Mongo has an ID, which is just the unique thing that describes the document. If you watched when I did an insert, here, I'll add another player. I'll add a guy named Dave. So insert returns the ID of that document. And I can even do a players.find and return a list of all the players. And if we just look at one, here's Joe's document, and you'll see the name and the score, but also that ID field. And that, by the way, did not go over the network, right? When I look through my database of players, that's just a local, fast operation. You'll notice it's synchronous. It just returns the results. So you don't have to write lots of callbacks and all these convoluted control flow structures. So in my event handler, I'm just going to get the ID for the object that's part of the thing I clicked on and set it in the session. Let's add a little class. So I'm going to make another handlebars helper is selected so that whatever player is selected is going to get annotated with a CSS class. So that's just a little addition to the class for that div. So I'll save that. And now let me define that helper. So template.players.isSelected is going to be a function. And I'll just say session.get player ID equals this.id. So that's the check to see if the document I'm rendering is the same as the one that's been saved in the session. And if so, I'll emit a selected class, otherwise no class. And there's that. And if I've done this right, I didn't do it right. I'm sorry? There's no? Oh, I did this wrong. I'm sorry. If I click on a player, let's try that. Oh, see, this is the perils of, so forgive me 1 second. I did this earlier this morning to make sure I knew what I was doing. It's selected. Click .player. It seems right, doesn't it? Class player. Let's see what's going on. So my handler's just not running. Click .player.
So the one difference I see is that template.player's events in the other one. And
Yep. Ah, thank you. It's always something. There we go. So yes, events ought to be defined on a template and not just in space. So when I clicked on the div, we're running this function which just sets the session ID, and now all of the elements on the screen are reacting, and whichever one is current is being highlighted. And of course, because session isn't persistent, those are different across the browsers. So we've got sort of data that's shared with a collection and then data that's separate. I owe you a beer. And so the final thing here is there's one other event, which is if we click on the button, right, well, what do we want to do? We want to update the player's score, so we can just use normal Mongo syntax. So we can do players.update. The key is session.get player ID, and in Mongo we can use the increment operator, so score increments by 5. And again, if we've done this right, man, it is not my day. Sorry? Thank you. There we go. And you'll see that they're live. So that's sort of the flavor of what it's like, right? The model here is that we've built a collection. The collection is shared because these are documents that all of the clients are subscribed to from the server. And then as we make changes, those changes become available to everybody at the same time. And we've eliminated that whole class of like boilerplate code that goes along with maintaining how do you, what's your REST endpoint, what's your invalidation cache server, how do you push all these updates to the clients, and so on and so forth. And that's just all wrapped up in how the collection works. Make sense? No questions? That's very rare. Yes? My thoughts on something like Derby. I know the Derby guys well. They're also, I think they would agree with all the slides. Like the future is single page apps, pure JavaScript. I think the big difference is that we've used, so for example, it's just Mongo in Meteor. I mean, you don't have to use Mongo, but that's the one we packaged first. So I'm just using the Mongo API. There's nothing special here. We can get into like how you'd publish only certain documents. So maybe one example I can just show you real quick is to give you a sense of how you start restricting what data each client can see. So I'm running Meteor in a mode called auto publish, which is what you get when you first make an app. What I can do is I can remove the auto-publish package. And you're going to see all the data disappeared from the client because I am no longer giving you this sort of, it's like Rails scaffolding, right? It's a good way to start writing your app, but not the way you're going to deploy it publicly. So I'm now responsible for telling each client what I want to give it. And I'll just show you sort of how intuitive that is. So back in my code, let me do an if Meteor is server stanza. And we're going to do meteor.publish. So meteor.publish is how I specify what I want to publish. So let's just start by all players. I'll name it something. And a publish function returns a database cursor. So I'm going to return players.find. And that will give me, there we go, all of my players in the database, right? And then on the client, I'm going to Meteor subscribe to all players. And now I have all my data back. So now I'm under this manual control where I've recreated what I had before, but explicitly what I want. And you'll notice it's just Mongo. So let me show you examples of like how that can work. One thing here is these guys are all out of, they're not really sorted. So I can go back to my template helper, and I can say I want all the documents, but I want to use Mongo sorting to sort by descending score, let's say. Right? And now I'm going to get all my stuff on the screen ordered by score, which is, again, you don't have to learn a new syntax or pick a new technology. It's just whatever database you're familiar with. Or we can go back to that publish function, and I can say I only want to publish players with a score bigger than 20, let's say. So my criteria is going to be score greater than 20. And now you'll notice I only have 2 players on the screen. My client just doesn't know about the third guy. And if I do players.find, there's only 2 objects, right? So the server's in control of who gets to see what. Or I guess this is a little contorted, but I can decimate the document. So I can say, I'll give you their name. So the publish will include, that's not right at all, sorry. The publish will ask for all documents with a score bigger than 20, but will only publish the name field and not the score. And so now we have our browser, and it doesn't actually know what the scores are, just the name in the document. So you know, our philosophy is like, Mongo's a great database. If you want to use Mongo, particularly if you are using Mongo and you have a lot of data already there, you ought to be able to write Mongo in your browser. So you ought to be able to use sort specifiers, or you ought to be able to do you know, queries where you say, I want to find only certain players for this particular you know, ordered list that I'm rendering. In another part of the app, maybe I want to do an aggregate and I just want the total score on the screen, or I want the top 5, or you know, anything like that. Yeah?
How do you do access restrictions? So if you have user-specific content that shouldn't be accessible by other users?
The question is about access restrictions. Against my better judgment, I can try to demo this.
You don't have to. I mean, just
No, I'd like to, because it's cool. I just have to beg your forgiveness if I can't figure out how it works. So the question is about access restrictions. This boils down to authentication. How does each client tell the server who it is so that the server can vary its behavior based on the client? Maybe I can do a really quick example of that. So let's add a couple packages. We'll add accounts Google and accounts UI. This is the work we're doing right now. So this is on a branch. It's on GitHub, but it's that's why I'm a little hesitant, because I haven't done this before. So accounts Google is a package that does OAuth to Google. So that's going to be our login service for this app. Accounts UI gives us some Chrome so that we can actually have some login buttons. And if I go to if I go back to my template, I'll just render this new, I think it's called login buttons template that I get from the new package. OK, so now I have a login with Google button on my screen. I need to do one little bit of configuration for talking to Google. And I have that somewhere. Here we go. So, you know, it's OAuth, so I've got an app ID which came from Google, and I've got a secret that came from Google. I'm putting all this in one file. You wouldn't do that. You can segregate your server-only code to another file, and you're obviously not going to ship that secret down to the client. So I've now told the system how to talk to this little app that I created on Google, and that's just a couple steps if you haven't done it. OAuth finally got it right. So Google, Facebook, providers that use that are really easy to integrate. So now if I click the login button, let's see if this works. So it wants me to log into Google. There I am. So that's my name. Again, I haven't written any code yet, other than just specifying these things. And if it was the first time, it would have said, like, do you want this app to have permission to see your email and so on? But I've used that app before, so Google already knew. So now back in the console, I can do things like Meteor.user. And Meteor.user gives me back a document, which is me. It's who I am. And if I log out and I look at Meteor user, it's null. So is that, can you guys see that? It's kind of toward the bottom of the screen. So that's on the client. Not such a big deal because we don't trust the client anyway. I also have that same information in the server. So now that I have this login infrastructure, I mean, this is a pretty cheesy app, but maybe one thing we can do is we just don't want you to see anything until you're logged in. I don't really care who you are, but I want you to be logged into the system. So I can go over to my publish function, and I can say if this.user ID, which is on the server, is there a user ID? Has the person logged in? I hope I got this syntax right. Then I'll return that cursor. But otherwise, I'm not going to return anything. So I'll save that file. And OK, I don't have any players on my screen. And if I log in, there's my players, right? And in the other browser, I'm in the same browser. That probably doesn't work. But over here, right, I'm not logged in, and so I don't see that. So that's the gist of auth in Meteor. Is we're going to clean up a lot of the Chrome that comes around it, but the basic idea is on the server, when you're publishing or when you're running a method on behalf of the client, you can look at who it is. And as that thing changes, the result of a publish, for example, changes along with it. So maybe only certain users get to see certain fields, or maybe, as I did, just nobody gets to see anything until they're logged in. Or maybe it just means that anybody can say increment the score, but I'm going to attach their name to that action. And so in the document, you'll be able to see this list of who did it. And again, that was all trusted server code, so a rogue client can't modify that document in some other way. Other questions? Yeah?
How do you get the Mongo API in the browser? What support is that?
The question is, how do we get the Mongo API in the browser? So we implemented Mongo in JavaScript. It's called Mini Mongo. It's one of the Meteor packages, and it just gives you, I mean, you know, when I went over here and said, you know, players.find, so this is a Mongo, or this is a JavaScript implementation of the Mongo API. It's not so bad because you're never going to have that much data in your browser. So the complexity of a database around, like, how do you actually lay the data out and performance and so on, That's not so important. What we've implemented is just the semantics of that query API and the update API. So, you know, when I run something like players.insert, what's really going on, getting back to that, that original slide, you know, score 55. What's really going on here is I'm locally inserting a document into my database. That's why the UI reacts so quickly, so that I get this immediate response on the screen. But I'm also calling the server, and I'm asking it to do the same thing. And eventually, what the server does comes back to me. So actually, if I did this right, we may see this work on the screen. I'm going to insert a document with a score of 55. That's going to appear right away. Let me make it like a really big score so that I know it's at the top of the page. The server is not publishing the score. So we're going to see a little bit of flicker because what the server sends back to me after a second is going to be just the name but not the score. And you'll see that score disappear. And that gives you a sense of how the client did something very quickly, but then once it saw the real version from the server, it updated with that. So let's see if it works. Yeah, there you go. That's kind of quick, but the effect is a lot more obvious if you're on the internet, right, where there can actually be some real lag between the two. Yeah? Yeah, the question is extensions to Meteor. So everything I've shown you is a package. What we have not done so far is make it easy. The packages are all in the repository. That's just temporary. So we'll clean that up over time. And yeah, anybody will be able to. We've already had people, for example, on the auth branch. They've implemented other login providers. Someone implemented Redis in JavaScript. Actually, so to your point, right, maybe you want to use Redis instead of Mongo. What you really want to make that work is the Redis API in the browser so that you can, again, write the same model code that runs on both sides. So he did it. So that, yeah, things like that are exactly what we're growing out. Anything else?
Just a question as
Yeah.
to, there's going to be a lot of exposure of your code on the client side and of your model.
Mm-hmm.
I'm just wondering about that ability, like inserting records in the database.
Yeah. So the question is about a lot of code getting shipped to the client and just like sort of security, I think, is what you're getting at. So it's a great question. First of all, let me be really clear. Like this is crap. What we would actually do is we would never put a secret like this in the code. What we would do is we'd make a server directory and then put this over there. So this never gets sent to the browser. So absolutely, like there is privileged code in Meteor apps. It does not go. It's just for a quick demo. We usually just keep everything in one file because it's clean. The other part is security, and I actually think there's a great story for single-page apps because we have this API. Like everything happening between the client and the server is that wire protocol that says you can subscribe to data and you can call methods. So we don't trust the client code at all. Right? I don't know what code you have running over there, and I don't know if someone added more stuff or if they're working in their console. The reason I can insert records in the database from the console is that we're running in that scaffolding mode where I haven't turned that off. But in a real app, you're just going to call methods. You're going to call something like, add to score, which takes a player ID, and that's a function on the server that's going to decide who you are. Are you allowed to do that? Right? Is it your player, or are you an admin, or whatever policy you want to impose? But there's one very specific point in the app where you can make that security decision. And I think that's actually a really strong story compared to a lot of what you end up seeing on server-side frameworks, right? Where you can do login at a lot of different points in the stack. Maybe they're like before methods on controller actions, or maybe you do that in your model layer, and it's just not as, I think, crisp as to where that policy gets imposed.
You use a token to verify a client, which is not something
Yes. So the question is how we identify the client. Yeah. So on the wire protocol, there's an authentication token. What you saw with the Google login is the Google package implements. It's actually very, very readable. The Google login package provides a method. I think it's called like login with Google or something, right? And so my client called. Well, it redirected to Google because there's the whole OAuth dance, but it ultimately calls the Meteor server with a method that says, here's my login token, and here's the credentials I got from Google that you can go verify because Google called you on the server side, blah, blah, blah. None of which you have to worry about. But now you have this replay token that you can use on the client to authenticate over the session. Yeah. Anything else? In the back? Yeah. The question is real apps. So we have a few. So this is what, 2 months old now. We have a few things that we've written ourselves. I mean, we wrote Meteor because we've done this for a while, and this is like what we've wanted to write our apps. There's a gallery actually on the website, madewith.meteor.com, which has some stuff. I think for the most part, until we release auth, you're going to see mostly people playing around with it. I've seen there's a really cool app that shows the real-time location of all the Muni buses in the city that someone wrote. That I think really shows off subscriptions and live updates pretty well. There's someone wrote a social music app, so there's rooms that you can listen to a shared list of YouTube videos in a queue. Someone yesterday released an app for scheduling sports leagues. So that uses Facebook auth, and it just says here are the teams you're part of, and it sends out mail with schedules and so on and so forth. So it's growing, but I really think auth, as we release it over the next couple months, is going to be the major impetus for most people to start building bigger stuff. Yeah. Cool. Thanks, guys.